Cool. That's it. Any questions?
So is that line in the middle where there's no strain at all, strain or stress?
Yeah.
Is that exactly in the middle all the way across?
So that depends on this thing called moment of inertia. For a beam that's symmetrical above and below, yeah, it'll be the same. It'll be right in the middle of the beam, the geometric center. For a beam that looks like this, if that's the cross section of the beam, this line is to be located somewhere down there, maybe 2/3 down probably. It'll vary a little bit, which is why you see like almost all beams are symmetric. Yeah. Cool. Yeah.
If I were to be in a relationship, at what point would it break?
So actually, it's funny you should mention that.
How much stress can I put on it?
How much time do I have? I have like 4 minutes. We're going to spend 5 minutes on a stress strain curve. So we remember how we put the reinforcement steel down there, right? Now there's this really funny thing where it acts exactly like a spring. Okay, so what this is, it's a graph. And on the top what you have is sigma x, that represents stress. So that's pounds per square inch. That's how much force is being resisted by like each square inch of the thing, right? This is eta. What?
What is that?
It's a sigma.
Stress. Oh, it's a sigma.
Oh, it's a sigma. He wrote it sideways.
To be clear, I weigh about 150 pounds.
You weigh about 150 pounds. That's relevant. So then the next thing here is strain. And strain is how much percentage-wise you stretch something. This is for steel, so I'm going to assume you're made of steel. That's okay. If you're made of steel, initially what you see, when you strain it up to about 0.003, so let's say you're 1,000 feet tall and I strained you 3 inches, that's 3 feet rather, there would be a linear relationship. So for every inch that I strain you, that's how much more is resistant. So we go to a relationship, right? For every date that you skip, we can assume up to the 3rd date, there's a linear relationship between how angry she gets with you. Right? That's fair. But at some point, you start anything else. All right, you wouldn't go on 1,000 dates. For Julie, this might be at 1.
3 seconds into the first day.
But the point is, there's a certain breaking point at which this is called elastic, because there's an elastic, it's a linear relationship. You get to the plastic range, and the stuff deforms rapidly. So it's actually flat. So almost no more stress. The stuff is just going to stretch all of a sudden. So I'd say this is when the girl gets really angry at you, and it doesn't matter what you're doing, right? It doesn't matter anymore. And she gets angry at you for nothing, right? You can't pick up the phone when you're in a meeting, and she's angry. This makes total sense though. So we call it. And there's one last thing where it's called strain hardening, and you never design for strain hardening. You design all your beams actually for this point, but actually at the very end, there's a point where steel actually gets a little bit stronger. And it's much like the relationship. She kind of needs to get over the hump and break up with you. But as in relationships,
I think you're taking this too far.
as in steel, you should never, ever, ever design for that, right? If you started designing for that ultimate stress, stuff would break.
Thank you.
Any other questions? I think I have one more, and then I'm gonna go.
So in other words, if you get to the flat there,
Yeah.
you should pretty much just break it off and redesign your relationship.
So yes, and we should break it off.
I mean,
reconsider your entire relationship. If a building, so that's the interesting thing is you design your building right for earthquake loads to get to this point. Let's say there's an earthquake, like at these reactors in Japan, right? They've gotten to that point. They've yielded. You design so that they yield. Once they've yielded, you have to tear the building down. Ideally, so ideally you don't get to that point. If you get to that point, yeah, no one dies, but your building's pretty much screwed. So that's kind of sad. Material's never the same again. The relationship. All right, excellent. That's all I've got. I'll hand it over to Charlie.
They're kind of the